Hello kids, the topic which we are going to discuss today is statistics. Let us quickly revise the concepts and formulae which you have done in your classes. To start with, measures of central tendency. Measures of central tendency. Here, two types of averages are there. First is mathematical averages, and the second one is position values or partition values. Under mathematical averages, we have arithmetic mean, which already we have discussed. Generally, we denote it by x bar. We have geometric mean, G, and harmonic mean of observations. Already we have discussed it. I would like to add on to this. Suppose you are given two groups. First group have n1 elements. n1 elements are given and whose arithmetic mean I will take it as x1 bar. आपके पास n1 elements है, arithmetic mean of those n1 elements is given by x1 bar, and second group n2 elements whose arithmetic mean is given by x2 bar. Now I am going to mix these two groups. So total I will be having how many elements? n1 plus n2 elements are there. Let us calculate, let us find what will be the average of these n1 plus n2 elements. So I will write the combined mean, the combined arithmetic mean of these n1 plus n2 observations denote combined mean of these two observations x bar is denoted by, just I am giving you the formula, n1 into x1 bar, n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. This is total observation. मुझे इसको 4 में divide करना है. How many values are required? 1, 2 and 3. First, second and third values. I am going to define quartiles which divides total observation into 4 equal portions, and the first one I denote it by Q1, second one is Q2, third one is Q3. So Q1, Q2 and Q3 are the quartiles, are the values which divide the observation into 4 equal portions. 25% of the observation will be less than Q1 and 25% Q1 Q2 के बीच में and 25% Q2 and Q3 के बीच में and remaining 25% will be more than or equal to Q3. अब आप बता सकते हो what this Q2 will be? देखो Q2 के left side we have 50%, towards the right of Q2 we have 50%. So Q2 is nothing but the median. Q2 is the second quartile. It is nothing but median of the observation. Now I am going to give you formula for finding out the first quartile Q1. It is given by L plus, formula is exactly similar to the one that of median, L plus, here Q1 less than Q1 we have only 25%, L plus, so it will be n by 4 minus Cf divided by F into H, where L1 will be the lower limit of the Q1 class, lower limit of the Q1 class. Then n total frequency, right, sigma I varies from 1 to n of Fi. F is the frequency of Q1 class, frequency of Q1 class, that is F. H is the class interval of Q1 class again, and Cf is the cumulative frequency of the class preceding to the Q1 class preceding to Q1 class. So in the case of median, what change is coming? L plus, there it will be n by 2 minus Cf by f into h. In the case of Q1, it will be n by 4. अब आप बता सकते हो what will be the corresponding formula for Q3? In case of Q3, instead of n by 4, it will be L plus, it is the third quartile, 3n by 4 minus Cf divided by f into h, right? For median, it will be L plus n by 2 minus Cf divided by f into h. So, these are formula for finding out the quartiles Q1, Q3 and median. Q1 is also called first quartile and Q3 is the third quartile. The next set of partition values, deciles. Deciles. Deciles आप बता सकते हो ऑब्जर्वेशन को कितने में डिवाइड कर रहे हैं? In 10 parts. They are D1, D2, etc. करके D9. We have 9 deciles. These 9 values divide the total observation into 10 equal portions. 10% will be less than or equal to D1, 10% D1 to D2 के बीच में, etc. etc. Similar formula. Try to write it. I am writing general one. Let's say D3. What D3 will be? L plus. Similarly, D3 के left side कितने percent observations है? 30%. So, it will be 3n divided by 10 minus Cf divided by f into h. So, I am writing a general one for the ith decile di is equal to L plus, instead of 3 I will write in divided by 10 minus Cf divided by f into h. L is the lower limit of the di class, I which decile you are going to find, n total frequency, f is frequency of the di class, h is the class interval and cumulative frequency of the preceding class of di class, that is denoted by Cf. Let us discuss the next set of partition values, percentiles. Percentiles, अब बताओ पूरे ऑब्जर्वेशन को कितने में डिवाइड कर रहे हैं? Yes, into 100 parts, first percentile, second percentile, etc. How many values are required? 99 values, and this will be the 99th percentile. Similar result follows. For example, let us write formula for P2. P2 is equal to L plus P2 ke left hand side. How many? 2%. So, it will be 2n divided by 100 minus Cf divided by f into h, and similar formula follows for the remaining percentiles. अब देखो, we have discussed quartiles, deciles and percentiles. Median, we have seen that it is the second quartile. Now tell me which decile will be median? D1, D2 से लेके D9 तक, it is D5. The fifth decile is median. Similarly, 50th percentile will be equal to median. Clear bete? Now, we were discussing measures of central tendency. As I told you, measures of central tendency में दो types होते हैं. एक तो mathematical averages, in which arithmetic mean, geometric mean and harmonic mean comes, and then we have partition values, position values. उसमें हमने discuss किया है median and mode generally, and plus percentiles, deciles and quartiles. Now, moving on to the next set, that is measures of dispersion. Measures of dispersion. The first formula which we are going to discuss is range. Range is the difference between the largest and smallest value. This is called range. Range of an observation is the difference between the largest and smallest value. The next average which comes under this topic, it is quartile deviation. Generally we denote it by QD. I will write the full form quartile deviation. Quartile deviation is defined as Q3 minus Q1 divided by 2. Batao, what is Q3? Q3 is the third quartile, Q1 first quartile, their difference divided by 2. gives you quartile deviation, and the next two already you have done. Mean deviation formula yaad hai? For a group data I will write mean deviation is given by 1 by n sigma fi into mod xi minus, I will just write a here where I varies from 1 to n. This a could be either arithmetic mean or geometric mean or harmonic mean as the case may be. Mainly it is the deviations from the observation we find and then take modulus. This is formula for finding out the mean deviation. Then comes standard deviation. Standard deviation. What is standard deviation? Sigma I varies from 1 to n fi ui square divided by capital N minus sigma fi ui divided by capital N the whole square, where I varies from 1 to n. This is variance. When you take the square root of this, you will be getting standard deviation, where ui's are the deviations xi minus a. Ui's are the deviations from assumed mean. Clear? Let us discuss some of the properties. Sigma xi minus x bar, I varies from 1 to n. What is this? The algebraic sum of the deviations of xi from the arithmetic mean. I will make it more clear. Let us open the sigma. x1 minus x bar plus x2 minus x bar plus x3 minus x bar etc. करके xn minus x bar. x1 minus x bar, the deviation of x1 from x bar, deviation of x2 from x bar etc. deviation of xn from x bar. That is the sum of the deviations of the observations from arithmetic mean is always 0. It is always 0. Now consider a set of observations x1, x2, x3 etc. xn whose arithmetic mean, let us take it as x bar, and let the variance be sigma square. x1 we have a set of n values x1, x2 etc. xn, arithmetic mean is x bar and variance is sigma square. Now I am going to add, let us say 3 throughout. So the observations becomes x1 plus 3, x2 plus 3 etc. xn plus 3. When you add a constant to all these terms, what happens to arithmetic mean? Also will be increased by the same constant, and variance it remains the same. Variance remains the same. Now subtract 3 throughout, subtract 3 original sequence x1 minus 3, x2 minus 3 etc. xn minus 3. Arithmetic mean again will be 3 will be subtracted from x bar and no change in variance, variance will be sigma square. I am going to multiply throughout by 3, multiply by 3, multiply by 3, observations are 3x1, 3x2 etc. thrice of xn, arithmetic mean also will be multiplied by the same constant, it becomes 3x bar and variance becomes 3 square into sigma square. Variance is 3 square into sigma square. Similarly, in the case of division, if you are dividing throughout by 3, x1 divided by 3, x2 divided by 3 etc. xn divided by 3, arithmetic mean x bar will be divided by 3, and what happens to the variance? It will be sigma square divided by 3 square, sigma square divided by 3 square. So what does it mean? Variance, it is invariant under shifting of origin, right? Plus 3 minus 3, if you add or subtract same constant throughout, variance remain unchanged whereas अगर आप add कर रहे हैं तो arithmetic mean it will be added, subtraction same number will be subtracted from arithmetic mean, etc. Properties are clear, beti? Now I am going to explain about symmetric and skew distributions. Symmetric and skew distributions. Frequency curve is said to be symmetric. I'll first of all make a graph of a symmetric one. It will be a bell-shaped curve, and in this case, look, the frequencies are placed equidistant from the central value. Graph will be a bell-shaped curve, frequency curve of a continuous distribution. It will be a bell-shaped curve and frequencies are placed on either side equidistant from a central value. So, if the distribution is symmetric, in this case this value here mean equal to median equal to mode, when if the distribution is a symmetric distribution. I will write here, in the case of a symmetric distribution, mean equal to median equal to mode. Graphically कैसे पता चलेगा? It should be a bell shape. If it's a bell shaped curve, the distribution is a symmetric distribution. Now let us discuss about skew distributions, that is which are not symmetric. So two possibilities are there: negatively skewed, or it could be positively skewed distribution. In the case of negatively skewed distribution, graph will be something like this. Here mean is less than median is less than mode. Mean will be less than median and it is less than mode. In the case of positively skewed distribution, graph is like this and this is R mode, exactly opposite to this. Mean is greater than median is greater than mode, or you can write it like this: mode is less than median, same thing, less than mean. These two distribution, they are not symmetric. Here negatively skewed distribution, mode जिसकी frequency सबसे ज़्यादा है, so this is mode, median middle value and arithmetic mean will be somewhere here, arithmetic mean, and this is median. Here mode जिसकी frequency सबसे ज़्यादा है, right, mode here, median, the middle value and arithmetic mean x bar will be somewhere here. Now I am going to give you one formula, very useful formula. In the case of skewed distribution, mean, median and mode are connected by this relation: mean minus mode equal to thrice of mean minus median. Very useful result. Learn, in the case of a skewed distribution, a distribution which is not symmetric, mean minus mode equal to thrice of mean minus median. Clear, bete? Let us proceed to the solved examples. First question is there on the board. Read the question. In any discrete series, all the values are not same. You have to find a relation between mean deviation and the standard deviation. Let us see how to solve this question. Write the formula for mean deviation and standard deviation. Standard deviation is given by under root of 1 by n sigma fi into mode xi minus x bar whole square, where I varies from 1 to n, right, and mean deviation is given by 1 by n sigma fi into mode xi minus x bar, where I equal to 1 to n. For the time being, I am going to take this quantity mod of xi minus x bar, taking it as di, just to make the calculation simple. So, what is our mean deviation now? Mean deviation is given by 1 by n sigma I varies from 1 to n of fi into di, and what is standard deviation? 1 by n sigma I varies from 1 to n fi into, look, mod xi minus x bar whole square is the same as xi minus x bar whole square. So, I can write it as di square inside the radical. I need to find a relation between mean deviation and standard deviation. We have the formula mean deviation and standard deviation. So, let us find sigma square minus mean deviation square. Sigma square means standard deviation square minus mean deviation whole square. Standard deviation square, put the values 1 by n sigma fi di square I equal to 1 to n minus square of mean deviation, which is 1 by n sigma fi di, where I varies from 1 to n whole square. Is this formula familiar? 1 by n sigma I equal to 1 to n fi di square minus 1 by n sigma I equal to 1 to n fi di the whole square. It is nothing but, I will write here, sigma d square. Variance, it is nothing but sigma d the whole square. We know that it is clearly greater than 0, that is standard deviation square. Standard deviation square minus mean deviation square is coming out to be greater than 0, implies standard deviation square is greater than mean deviation square. Both of these, they are positive quantities. So, we can write this implies standard deviation is greater than mean deviation. Check out the option, which one is correct? Standard deviation is greater than mean deviation, or we say mean deviation is less than standard deviation. Option C is correct. Okay, bete? Let us proceed to the next question. Question number 2. Let us see what all things are given. Sum of n minus 5 values is given to be A. You have to find the mean of 5 values. So, let us take it to be m, and you are given arithmetic mean of n values as x bar. So, apply the formula, very simple question, x bar equal to a minus 5, n minus 5 values, n minus 5 into a divided by n minus 5, sum is a. So, arithmetic mean will be a divided by n minus 5 plus 5 into 5 values, sum is m divided by n minus 5 plus 5. n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2 formula applied. Just cross multiply n into x bar equal to a plus 5m, from which easily we can get the value of m. What is m? m equal to n x bar minus a divided by 5, that is mean of the remaining 5 observations. M is given by n x bar minus a divided by 5. A very simple question based on the concept of arithmetic mean. Clear, bete? Let us proceed to the next question. x1 bar and x2 bar are arithmetic means of two distributions such that x1 bar less than x2 bar and the combined mean is given. Combined mean x bar is given by, formula batao, n1 x1 bar plus n2 x2 bar divided by n1 plus n2. We have to find a order relation. We have to check which of these given relations are true. So, for that I am going to calculate x bar minus x1 bar. X bar we have put the value n1 x1 bar plus n2 x2 bar divided by n1 plus n2 minus x1 bar. Simplify, n1 x1 bar plus n2 x2 bar minus n1 x1 bar minus n2 x1 bar. Look, which term is getting cancelled? Divided by n1 plus n2, which simplifies to n2 into x2 bar minus x1 bar divided by n1 plus n2. What is this? It is x bar minus x1 bar. Read the question again. What is given to you? x1 bar is less than x2 bar. Here we have x2 bar minus x1 bar. So, this quantity will be clearly greater than 0. N1 number of observations, N2 number of observations, they are positive. So, from here we get, right here, from here we get x bar is greater than x1 bar. Similarly, you find x bar minus x2 bar, just put the values and simplify. We get a similar result. We get it as n1 into x1 bar minus x2 bar divided by n1 plus n2 x1 bar minus x2 bar. This is less than 0, which implies x bar is less than x2 bar. Combine these two relations. We have x bar greater than x1 bar and x bar less than x2 bar. See which option is correct? x1 bar less than x bar less than x2 bar. Option D is correct. Clear, bete? Look, what we have done here, x1 bar less than x2 bar there and combined mean. Combined mean, we have written the formula, we have to check out of these which option is correct. So, I have taken x bar minus x1 bar, calculated its value using the given data. I got the value of x bar minus x1 bar is a positive quantity, which implies x bar is greater than x1 bar. Similarly, we can find x bar minus x2 bar, which comes out to be n1 into x1 bar minus x2 bar divided by n1 plus n2. Again, n1, n2, they are all number of observations, always positive, and given x1 bar is less than x2 bar. So, this is negative. From here, x bar is less than x2 bar. अब मैंने क्या किया? I combined these two results to get the option D. I hope it's clear to you. I hope you have understood all the concepts and questions which we have discussed today. Do solve the examples once again, practice the question given in the exercise. In case of any problem, get back to us. Thank you.